Hi everyone, it's Ken Ramirez with another weekly geology video. This week my topic was to research an earthquake or some volcanic activity that was significantly damaging, and I chose to research the Sumatra Andaman earthquake that happened in the Sumatra Andaman Islands in 2004. So on December 26, 2004, for around 10 minutes, the initial earthquake happened up to a 9.1 magnitude on the scale. It was the most energetic earthquake swarm ever recorded, including its aftershocks. And the whole event, they reckon, went on for around an hour. Um, Notable things, the fault slipped an average of 33 feet on the fault line, with some areas slipping up to 50 feet. It was the largest fault rupture ever recorded, and it was around 1,600 kilometers of the fault boundary that ruptured. And the aftershocks had a magnitude of 6 or greater, or lesser, obviously, but large magnitude in the aftershocks, which attributed to it being the most energetic earthquake swarm ever recorded. As far as cost goes, around $14 billion in aid and in general from the countries that it happened in was accumulated. So it was a pretty costly event, pretty costly cleanup, especially after the tsunamis were generated after the initial earthquake. As far as tectonics go, the India plate is being subducted underneath the Sunda plate, specifically under the Burma microplate. And this is a convergent boundary. It's a subduction zone, obviously, as the India plate is being subducted underneath the Sunda plate. And it's a megathrust strike slip fault, which attributed to the large rupture in the fault line and the violent activity that happened to cause this earthquake and eventually uplift the sea floor or the ocean floor and cause the massive tsunamis that occurred shortly after the initial earthquake. Damages, you saw on the first slide, there was just absolute destruction, large amounts of flooding. Around 500,000 people were displaced from their homes in Sumatra alone. 131,000 reported dead initially, and close to 40,000 were reported missing. Around 80,000 homes were destroyed or severely damaged. Most buildings and houses were victim to the tsunamis after the earthquake. The earthquake itself, while it was extremely damaging and strong, tectonic subsidence and liquefaction contributed to damages mostly after the tsunami, and obviously the tsunami waves itself did a lot of damage as well to things such as fuel storage, light structures, and well-anchored buildings that were ruined. The ocean floor was uplifted by the fault rupture, and the tsunamis were generated. Waves ranged from 4 to 39 meters high, and they destroyed upwards of 250 communities along the coastlines. Roads and bridges were ruined, and survivors were only discovered and helped by boat and helicopter. That was pretty much the only form of transportation for several months after the earthquake and the tsunamis that followed it. As for future implications, here's some more damages, as you can see from the previous slide. But for future implications and protecting against these hazards, it's important to use engineering and architecture that's focused on combating severe earthquakes and tsunamis and the like, especially in this active area, and enhancing community buildings and schools for post-disaster spaces for people to go and be taken care of. But other than that, it's mostly talked about that it's very difficult to protect against these, and especially to prevent them. Obviously, they're random and we cannot prevent them. Thank you for watching, and I'll talk to you guys next week.